everyone. My name is Tanu Rajput and let me introduce with my team members Kajal Dhona, Naveen Kumar Samhari. I am here with my third caption project, Mobile Price Range Prediction, which is a supervised machine learning classification problem. So firstly, let's check the problem statement. As we all know, mobile phone has become a necessary for every individual nowadays. Everyone wants a mobile phone with all the features and best specifications, and that too in cheaper prices. So mobile prices are an important reflection of the humans, and some ranges are of great interest for buyers and sellers. In the competitive mobile phone market, companies want to understand sales data of mobile phone and the factors which drive the prices. Price estimation and prediction is an important part of consumer strategy. So, deciding on the correct price of a product is very important for the market success of a product. So, the objective is to find out some relation between features of a mobile phone and its selling price. This project will classify the price range of the mobile price, indicating how high the price is. So, coming to our next slide, we will see the content of our presentation and of our project. So firstly we will discuss about the data description. After that we will see how we wrangle the data by talking about the mismatch columns and its handling. And after that we will also discuss about the outlier treatment, and after that we will see how we explore the data, and that is exploratory data analysis. And after that we will see how our features are correlated with the target features and correlated with each other. And after that we will see the model list and their evaluation metrics we are using for our project. And after that we will see that which model we use for our prediction, or we will see the best optimal model for our project. And after that we will see the challenges we faced, and we will wrap up everything with the conclusion at the end. So next, let's see with the data description. We have some features like battery power, clock speed, front camera, memory, mobile depth, mobile weight, number of cores, primary camera, pixel height, pixel resolution width, RAM, screen height, screen width, and talk time, which are numerical attributes. And some categorical attributes like it has Bluetooth connectivity or not, it has dual SIM or not, is it 4G or 3G, is it touch screen, or it has Wi-Fi or not. And at the end we have our target feature, which is price range. So now let's take a peek at the dataset we have. This dataset contains 2000 rows and 21 columns. As we can see, no null values in any attribute. It was observed that the categorical attributes are already encoded. So we didn't require any feature encoding processing here. Our target features price range, and the rest features are the independent attribute. Next we will see the data wrangling. Talking about the mismatch values in column and its handling. And checking number of observation in both attributes having values as 0. Firstly we will check the number of observation in both the attributes having values as 0. As we can clearly see, number of observation having pixel height as 0 are 2, and number of observation having screen width value as 0 are 180. So next we will see the handling pixel height attribute, which contains 0 as value. So here we can see that we drop the data which has a pixel height as 0. Now let's see that how we handle the screen width attribute. It contains 0 as values. It contains around 179 rows with 0 value. So we decide to replace method, then we use KNN imputation method. So after handling such mismatch errors, the shape of the data set shows that 1998 rows and 21 columns. Now let's see the data wrangling, where we have treated the outliers. So let's see the treatment of outliers. In the given picture, columns such as front camera and pixel height contain outliers. So we decide to remove outliers of these columns by using the quantile method. Excluding these two columns, rest of the attributes doesn't contain any outliers. So coming to our exploratory data analyze, we will firstly see that how our target variable is distributed. So target feature have almost equal number of observations. It is distributed equally. Percentage distribution of price range is 25% each. And the binary categorical variables analysis, here we can clearly see the distribution of Bluetooth connectivity, dual SIM, 4G, 3G, Wi-Fi, touch screen. We can here see that percentage distribution of mobile having Bluetooth, dual SIM, Wi-Fi, touch screen are almost 50%. And speaking about the 3G attribute, around 76% of the mobiles have the 3G features, and around 23.9% of the mobiles doesn't have these features, and we can clearly see this in the chart. Now let's discuss about the price range versus RAM, battery, power, pixel height, pixel width. So mobiles having RAM more than 3 GB comes under 3 price range category, that is very high cost category. Mobile with battery power more than 1300 mAh comes under very high cost price range category. So mobile phones with more than 700 pixel height and width then 1300 has very high cost. So let's check the count of mobiles contain 3G and 4G features. So in the first chart, we can see the mobile with 3G and 4G features, and in the second chart we can see the mobile not having 3G and 4G features, where we can say that the number of mobiles which contain 3G and 4G features is high, which falls under very high cost price range category, and in the second pick with the number of mobiles which doesn't contain 3G and 4G features is high, which falls under very low cost price range category. Now let's see the count of mobiles in each price range with supporting or non-supporting specifications like Bluetooth connectivity, dual SIM, 4G, 3G, touchscreen and Wi-Fi. Each price range category has equal number of mobiles having both supporting and non-supporting specifications. Now we will see the count of mobiles for each number of cores and mobile depth with respect to the price range, which is our target feature. So we can see that there are few mobiles in price range 0 and 1 with lesser number of cores, and the count of mobiles contain cores like 5, 7 and 8 is high, and number of mobiles with less thickness is high with respect to price range. Now moving to the next slide, here we can see some independent features versus target feature. We can see that price range and price range with the maximum depth and mobile depth and battery power. So there are some independent features versus target features where we can see that how price reflect with respect to these features like mobile depth and battery power, memory and etc. And here are as same independent features versus target features. So moving to our next slide, here we will discuss about correlation analysis. Let's talk about the relation between some of the attributes like price range and RAM. We can clearly see that price range and RAM are highly correlated with each other. If the if the RAM is higher, then the price range will also higher. And second, we have primary camera and front camera, which are also highly correlated, and same as primary camera and PC height and PC width and price range and battery power and 3G and 4G are also very high correlated with each other, and 4G and 3G are also highly correlated, as we all know that most of the mobile phones provide both the features nowadays. So it was our correlations amongst all the features. Now we will see the model. Here is the list of algorithms we use: logistic regression, super vector machine, random forest, decision tree classifier, k-nearest neighbor. And here we can see the evaluation metric with hyperparameter tuning. We can clearly see that we have logistic regression and super vector machine has the highest train accuracy, highest test accuracy, highest train test precision score, highest train test recall score, and F1 score also. But here we will choose according to the model evaluation matrix data frame. The test score of random forest and decision tree classifier are nearly same. So the best result that we are getting from logistic regression and super vector machine, but we are selecting the super vector machine for model selection and prediction. Now let's discuss the challenges we face during the project. First challenge we face while handling mismatch values in few columns. We felt a little challenging when we start working on different algorithms and its matrix, and also choosing quite number of algorithms to work upon. And also we face a little challenge when deciding about the best model for prediction. So let's wrap up all the things with the conclusion. Now, with data exploration, we found that the price range is mostly affected by RAM, pixel height, pixel width, front camera, primary camera, battery power, and 4G. As higher the range, higher the price. Performed modeling using various algorithms, and also evaluated metrics such as training score and testing scores. So after hyperparameter tuning, we got to know that the best predictive model is super vector machine with the training score 0.98 and testing score 0.95. So we decided to choose super vector machine as our predictive model. Thank you.